Hi there, in this video we're going to learn about negative exponents. Your objective for today is to write expressions using positive exponents, write expressions using negative exponents, and to evaluate numerical expressions containing negative exponents. So let's first understand what a negative exponent is. A negative exponent is an exponent that results from repeated division. So if we look on the left side of this table, the exponents go down by 1 each time. 3, 2, 1, 0, negative 1, negative 2, negative 3. If you look on the side where it says standard form, these numbers each get divided by 10 to get to the next number. So really we're going to focus on the bottom half of this table. The exponents, or I should say the numbers with the negative exponents, those are used to describe really small numbers in math and science. They're used all the time. So in math and science, instead of writing out the fractions or even the decimals of 1/10, 1/100th, or 1 over 1,000, 1,000s, I should say, instead of writing the fractions, you would just write 10 to the negative power. You know, in science, if you have like something like 1 over 1 million, you wouldn't want to write 1/1,000,000th as a fraction. You would want to write 10 to the negative 6. That's just easier to write. All right, so the negative exponent property says that in order to turn the base with a negative exponent into a base with a positive exponent, you need to put it in the denominator and raise it to the positive power. So this whole thing, a to the negative n, is going to get sent to the bottom, and the power is going to change to a positive power. Really, there's like a 1 in front of this a that we don't normally write in math, but it is there, and that's where the numerator of 1 comes in from. So again, we're going to send this to the bottom, and the power of negative 2 is now going to become a positive power of 2. So it'll end up being 1 over y squared. In the next few examples, we're going to write expressions using positive exponents. So here we have 2 to the negative 3. We're going to send this down to the denominator and make it have a positive power. So it'll be 1 over 2 cubed. In the next example, same thing. We're going to take this and we're going to send it to the bottom, and we're going to turn the power positive. So we have 1 over m to the 4th. And in the last example, same thing. We're going to take the whole thing. Notice the parentheses. The negative 5 is in parentheses. Make sure that you keep the parentheses. So this whole thing is going to be sent to the bottom, and the power is now going to be positive. So 1 over negative 5 cubed. In our next example, we have 8y to the negative 4. Now, you have to know that the negative 4 is attached only to the y and not to the 8. So, this could actually be rewritten as 8 times y to the negative 4th power. This is easier for you to the negative 4 is attached only to y. And now we would just multiply it as you would any whole number times a fraction, right? So this we send to the bottom with a positive exponent, and then we multiply. So we would just do 8 times 1, and we get 8, and then 1 times y to the 4th, which is just y to the 4th. All right, so this is a lot of work. There is a shortcut for this, which I'm going to talk about in the next slide, but you know me, I like to explain where the shortcuts come from. So, all right, so the shortcut is, you can think of this as any base with a positive exponent will be kept in the numerator. Send any base with a negative exponent to the denominator, now with a positive exponent. So, this 8y negative 4 from our previous example is the same thing as saying a to the 1st times y to the negative 4th. Now, there's always an exponent next to numbers. If you have like a number 8, like we do here, there's really a 1 attached to it as an exponent. So it's a to the 1st power times y to the negative 4th. So this a power is going to be kept in the numerator because the exponent is positive. This y to the negative 4th power is going to be sent down to the denominator because you have a negative exponent. And now that negative exponent is going to change to a positive. So we have 8 to the first over y to the fourth. Now I think it's a lot easier to circle the base with the negative exponent so that you can easily see what will go in the denominator. That's just a little hint that I have. So I circle this, and I know to send that to the bottom and change the power to be positive. And then I have 8 over y to the fourth. That's what it is simplified. All right, and in the next few examples, we're going to write expressions using a negative exponent other than -1. So in example A, we have 1 over 4 squared. So now we're going to send this up. Instead of a positive exponent, now we're going to have a negative exponent. That's how you get rid of the fraction. Over here we have 1 over 100, which would really be 100 to the negative first power, but our instructions say an exponent other than -1. So you could actually write this as 1 over 10 squared, and that would actually just be 10 to the negative second power. All right, and now we're going to evaluate expressions with negative exponents. So we have evaluate for a to the negative fifth if a equals -2. So we're going to plug in -2 for a, and then rewrite the expression using positive exponents, and then we're going to solve. So we have 4 times -2 to the negative fifth. All right, notice the parentheses. The negative fifth is attached to the -2. And the negative fifth power is only attached to the -2, right? There really is an exponent of 1 here that we don't normally see or write. You are welcome to write it on your paper if you want, but it's not simplified if you actually write that in your final answer. So don't write that in your final answer. All right, so now we know that we're going to send this to the bottom, and we're going to keep this in the numerator. This is going to the bottom. -2 to the negative fifth power is going to the bottom because of the negative exponent. So we have 4 over -2 to the positive fifth power now, and we're just going to solve. So it's 4 over -32, which simplifies to 1 over -8, or -1/8. Okay, and in the next slide we have 6mn to the negative fourth power. M is 4 and n is 3. So make sure you understand the -4 is attached only to n and not to the 6 and not to the m. Let's plug in our numbers. So we're plugging in 4 for m, 3 for n, and put parentheses around. It's easy to put parentheses around when you're dealing with negative exponents. It's so much easier to see things that way. So this is going to be sent to the bottom. 3 to the -4 is being sent to the bottom because of the negative exponent. So once it gets sent to the bottom, the power becomes positive, and then you have the 6 times 4 in the numerator. 6 times, whoops, sorry about that. So we have the 6 times 4, which gets you 24. The 3 to the fourth power is 81. And then that simplifies to be 8 over 27. All right, so just some concluding thoughts. You want to keep any base with a positive exponent in the numerator. You want to send any base with the negative exponent to the denominator, now with a positive exponent. So you would change it to a positive exponent. And then you want to circle the bases with the negative exponent so you can easily see what you are sending to the bottom. Alright guys, I hope you learned about negative exponents. Thank you for watching.